All right, so our final step. Here are the lines that we used to calculate our prediction. That we kind of skipped over that, but we were about 65% accurate in this case. But the final step is to predict. Sorry, here's the 65. I'm getting ahead of myself. The final step then is to apply our data, our new decision tree model, to all of our original data. So this line uses the getValues function to pull all of the pixels from our raster data set. That returns a matrix. We need that as a data frame. So we dump that into the data frame command so that it is formatted correctly. Line 45 here, we're going to use the predict command to predict based on our pruned decision tree. We're going to supply the new data that we want it applied to, which is our all data, which we just created up here in the previous line. And we want the class to, the result, the type to be class, so that I don't want the numeric prediction value back. I want it to either say dry, wet, or none. Once that's done, though, in 36 here, I need to know the order in which all of that was supplied. And if I don't, so the default is to do it in alphabetical order. Here I'm changing it, though. So I'm creating an ordered factor, ordered to set equal to true. We're setting as it a factor, and my levels are none, dry, and rainy. So number 1 in my final raster, a number 1 will mean there are never gorillas there. A number 2 will mean there are gorillas there during the dry season, and a number 3, or sorry, 0, no, yeah, 1, 2, and 3. And the 3 will mean that there are gorillas there during the rainy season. Down here, I'm just creating a copy of the elevation data set. I'm going to replace those elevation values with my predicted values. Here, it turns out that the decision tree predictor predict function has a hard time with missing data, or no data, which is everything that's falling outside of our study area. So here I am I'm asking R to remember the pixels that should be filled with no data. So I'm asking, is that pixel value no data, and if so, which one is it? Here I'm just replacing the pixel values in my copy of the elevation data set, which I called ANS. I'm replacing that with the results of my model from this line up here. And here I'm just going back through and making sure R understands that those pixels that were no data still need to be no data. So I'm setting those equal to NA, and here I'm just plotting the results so I can take a look at it. This last line, if I want, will save that result to a TIFF file that I'm calling decisiontree.tiff that I can open up in any QGIS that I want. But if I run all of these lines here, I recreate the model, and so here's my prediction. Anything that's gray has gorillas never. Anything that's at a number 2 has pixels during the dry, or has gorillas during the dry season, and anything that's green has gorillas during the wet season. And you can save this to the GeoTIFF if you want, but to get full credit on this lab, you just need to send me a screenshot of this map right here, and we'll be good to go.